In today's video, we are going to be looking at QuickSort for arrays. So there are some subtle differences between QuickSort for array and QuickSort for linked list. Today's video will be just looking at QuickSort for arrays. So QuickSort is the fastest comparison based sort for arrays. So there are some non-comparison based sorts like counting sort, which in certain special cases is faster than QuickSort. But if you don't know anything about the array and your program just gets an array of integers and you have to sort it, this is a good sorting algorithm to go with. Even in Java, when you do arrays.sort and you pass in an array of integers, underneath the covers it uses QuickSort. So the average running time for QuickSort is big O of n log n. The worst case is big O of n square. So this algorithm involves selecting a random index called pivot. If you select that index randomly, you won't end up here. If you select that index like the first element or the last element, something like that, then you might end up with big O of n square. So select the pivot index randomly. So you'll end up here. The space complexity is big O of n log n. So now this is an in-place sort. This arises from the fact that we use recursion. And in recursion, you use stack frames. So stack frames is from where you're getting the n log n space complexity. So these are the rules. I've abbreviated the rules over here. So in the description below, I have the solution to this problem. The QuickSort, I have the Java solution in the description below. I've also referenced a Leet code problem number where you can copy paste the solution, play around with it. So in the solution, I have the rules in detail. Here I've abbreviated it to make it fit on the board. So let's start with this example. I'll use these rules on this array, so it's easier to explain with an example. And QuickSort is a little tricky to get it right the first time, so you might have to do like 2 or 3 attempts before you get it right. Of the sorting algorithms, I think this is one of the tricky ones to get the coding right. The concept is kind of easy to understand. So the basic principle here is we select a random element in the array called pivot, and we move all elements bigger than pivot to the right of the pivot and all elements smaller than the pivot to the left of the pivot. And we keep recursively doing this on both sides of the pivot. Ultimately, your whole array is sorted. So let's see an example. The first thing you do is select a random pivot index. Suppose I select 3 as my random pivot index. Then you move the pivot element to the extreme right. So you swap it with this element. So what I'm going to do is I'm going to use red so that we know which one was the pivot. So that's the second step. Then I pointer, so we have 2 pointers, I and j. I pointer before start of array. So this is important. I'm not putting it at 0. Remember that. I'm putting it before the start of the array. And j pointer to the extreme right, which is the pivot. So this is where your j pointer is. Now, see, like I told you, our aim is to move elements bigger than the pivot to the right and less than pivot to the left. So the way we do it is we move this pointer until we find an element which is greater than equal to pivot, which is this step. Move I till it reaches greater than equal to pivot here. So I already found it. J, move it to the other direction until we find an element less than the pivot. Found it. Okay, we came till here. Now you swap elements in I and j. So now you take the small element, move to the left, big element to the right. Okay, so now we will continue. Repeat until I greater than equal to j. Again move this until you find an element greater than equal to pivot, which is here. Move this until you find an element less than, like this, like this, like this. But now we have crossed this condition. So if this condition is met, this takes precedence. I greater than equal to j, then you swap I with the pivot. So you do this, and now if you observe, everything to the right of the pivot is bigger, everything to the left of the pivot is smaller. So now you get the general idea, right? This is what we're trying to do for the whole array. So now, since this is a recursive algorithm, we do this on the left, but on the left, you just have one element, and one element is always sorted, so no need to sort this anymore. Then we go to the right. Now right is 2 to 5. Again, let's start here. Random pivot index. Suppose again I pick 3 as my random pivot index. Move pivot to extreme right. Move this here, and I'm going to replace it with a red element so that we know which one's the pivot. Okay. Now the next step, I before the start of the array. So we are sorting between 2 to 5. I will come at 1 and j will be at the extreme right, which is at the pivot. Now again we do the same thing. This is I, this is j. Again we'll do the same thing. Move I until you find an element greater than or equal to pivot. Okay, now this is again, remember, you have to move I first. If you move j first, your algorithm will end up in wrong result. Always move I first. You move I bigger than pivot. Okay, 5. This less than or equal to. Okay, now I've met this condition. Swap elements in I and j. Okay, now again move I until you find an element greater than or equal to pivot. Stop here. J less than or equal to pivot. Stop here. But now I has crossed j. So if I has crossed j, that takes precedence and you swap it with the pivot. I with the pivot. Okay. Now again observe, everything to the right of the pivot is bigger, everything to the left is smaller. Since this is a recursive algorithm, now we'll do same on the left of the array. When we come left, it's only one element. Don't need to sort. Now we go right. Now again right, 4 to 5, do the same thing. Choose a random pivot index. Suppose I choose this as my random pivot index. Okay. No need to swap this right now because it's already at the right end. Choose a random pivot index. Extreme right, we already moved it to extreme right since it was already there. I before start. So I will come here at 3. J extreme right at the pivot here. Move I until you are greater than or equal to pivot or right end. So we move I here. Move I here. Sorry, this is move I here greater than or equal to pivot at 10. And now move J until less than or equal to pivot or left end. So I has already reached the left end. J has already reached the left end. Now we have met this condition, I greater than or equal to j. Now we will swap I with the pivot. Swap I with the pivot. And now we will do recursively on the left and right. Left is already sorted. We come right, just one element. So that's also sorted. So now if you look, the whole array is sorted. So this is pretty much what QuickSort is. So go ahead and take a look at the solution in the description below. And if you like the video, don't forget to put a like and subscribe. Thank you.